Assalamualaikum and hello everyone. My name is Ahmad Zaim Zakaria. My matric number MA23051, and today I will be presenting a blueprint for process improvement using the Six Sigma DMAIC methodology. In today's highly competitive engineering and manufacturing industries, organization continuously face challenges such as inefficiency, defect, delays, and increasing operational costs. To overcome these issues, a structured problem-solving approach is needed. DMAIC is one of the most widely used methodologies in Lean Six Sigma because it provides a systematic and data-driven framework to identify problems, determine their cause, implement improvements, and sustain long-term results. Throughout this presentation, I will explain each phase of DMAIC and demonstrate how it helps organization achieve operational excellence. This slide illustrates the overall concept of DMAIC. Think of an organization as a pipeline. At the beginning of the pipeline, we often encounter infrastructure process inefficiency, waste, and recurring problems. Without a proper system, these issues can reduce productivity and increase operational costs. The MAIC acts as an engineering engine that transforms these problems into opportunities for improvement. Through data collection, analysis, and process optimization, organization can improve efficiency, reduce defect, and achieve more consistent outcome. The final result is a streamlined process that delivers higher quality product and service while utilizing resource more effectively. Before discussing the five phase, it is important to understand why DMAIC is so valuable. The first benefit is that it provides a structured roadmap instead of solving problems randomly. Teams follow a clear sequence from problem identification to solution implementation. The second benefit is data-driven decision making. DMAIC relies on actual performance data rather than assumption or personal opinions, making decision more accurate and reliable. The third benefit is improved productivity and efficiency by eliminating waste, reducing defect, and optimizing workflows. Organization can save time, reduce costs, and improve customer satisfaction. These benefits explain why DMAIC is widely adopted across manufacturing, engineering, healthcare, and service industries. This slide summarizes the five phases of DMAIC. The first phase is define, where we clearly identify the problem. The second phase is measure, where we collect data and determine the current performance level. The third phase is analyze, where we investigate the root cause of the problem. The fourth phase is improve, where solutions are developed and implemented. Finally, the control phase ensures that improvements are maintained over time. Together, these five phases form a complete cycle for continuous improvement. The define phase is the foundation of the entire DMAIC process. At this stage, the team focus on understanding the problem clearly before attempting to solve it. This include identifying customer requirements, project objective, and the overall scope of the project. One common mistake organization make is jumping directly into solution without fully understanding the problem. DMIC avoids this by emphasizing problem definition first. The outcome of this phase is typically a project charter, which serves as a roadmap for the entire improvement project. Once the problem has been defined, the next step is measurement. In engineering, we cannot improve what we do not measure. Therefore, the measure phase focuses on collecting accurate and reliable data about the current process. The team identify key performance indicators, gathers baseline data, and evaluates the current level of performance. This baseline becomes the reference points against which future improvement can be compared. Accurate measurements are critical because poor quality data can lead to incorrect conclusion later in the project. After collecting data, we move to analyze phase. The goal here is to identify the true root cause of the problem rather than simply treating the symptom. For example, if production defects are increasing, the actual cause could be machine wear, inadequate training, poor materials, or process verification. Various analytical tools such as fishbone diagram, Pareto analysis, and the five ways technique can be used to investigate the issue. At the end of this phase, the team should have strong evidence supporting the identified root cause. Once the root cause have been identified, solution can be developed. The improve phase focus on generating ideas, testing alternative, and implementing the most effective solution. Rather than making immediate large-scale change, organizations often conduct pilot testing first. This helps verify that the proper solution actually works and does not create new problem elsewhere. The objective is to optimize the process by eliminating the root causes identified in the previous phase. A successful improve phase leads to measurable gains in quality, productivity, efficiency, and customer satisfaction. Many improvement projects fail because organizations do not maintain the improvement achieved. That is why the control phase is extremely important. During this phase, new procedures are standardized, monitoring systems are established, and performance indicators are continuously tracked. Control charts, dashboards, audits, and standard operating procedures are commonly used to ensure that the process remains stable over time. The objective is to prevent the organization from returning to old habits and ensure that improvement becomes permanent. This slide highlights an important principle of DMIC. Continuous improvement never truly ends. Once the control phase establishes a new baseline, organization can begin another cycle of DMAIC whenever new opportunities for improvement arise. This creates a continuous loop where processes become increasingly efficient, reliable, and competitive over time. In other words, DMIC is not a one time project, but an ongoing journey toward operational excellence. Lastly, in conclusion, DMIC provide a structured and systematic approach for solving organization problems. Through the five phases of define, measure, analyze, improve, and control, organization can identify issue accurately, make data-driven decision, implement effective solution, and sustain long-term improvement. The methodology helps reduce defect, improve efficiency, lower operational costs, and increase customer satisfaction. For engineers and future industry professionals, understanding DMMIC is essential because it provides a proven framework for achieving continuous improvement and operational excellence. Thank you for your attention. I welcome any question regarding the presentation.